In the last video, we found out how to find the middle element of an array that contained an odd number of elements. Remember, we did so by first determining it was odd by using modulus. So we took the array, found its length, performed a modulus 2 on it, and if there was a remainder of 1, the number of elements must have been odd. So we simply um, chopped off the decimal of a division by 2, because remember, if you take an odd number and divide by 2, you're going to get a 0.5. So we use the floor function to chop off that 0.5 once we divided the number of items in the array by 2. And that gave us the proper index number, since the index number starts with 0. For instance, if you take 7 elements and divide by 2, you get 3.5. If you chop off that decimal using the floor function, you get 3. So since it starts with 0, you get 0, 1, 2, 3, or the fourth element. Now this would still work if there were 81 elements. 81 divided by 2 would be 40.5. Chop off the 0.5 and you get 40. The index number of 40 in an array with 81 elements would be the middle one. Now let's determine what we do if there are even numbers, if there's an even number of elements. Well, this checks to find out if there's an odd number of elements. So the implied else clause, so we'll go else. In this case, that would enter this block if it wasn't um, odd. Now it could be 0, and we're going to leave that check out for right now. But if it reaches this else case, and we ignore the case of 0 for now, that means it only enters this area when it's even. Now remember, if it's even, let's take an even number of 6. The algorithm would be to take the middle two, in this case 3 and 4, and average them, or add them up and divide by 2. So that, in this case, since there are 6 elements, we would actually be using index numbers 0, 1, 2, and 3. Now, if we were to divide an even number of elements by 2, we'll get a nice even number. So 6 divided by 2 will give us 3. Well, that would be the index for this second one, because it starts with 0. Remember, 0, 1, 2, 3. And then if we just reduce it by 1, we'll get this other element. So it looks like there's the algorithm. Take the number of elements, divide by 2, use that index, and then reduce that index by 1 and use that index. So in other words, we're going to add a list, a number, and add another number, and divide that quantity by 2, because we're going to find the average, and that's what we want to return. So this number and this number will be added, divided by 2 to find an average and return. But which ones do we use? Remember, we just take the length and divide by 2 to get the higher of the 2 in terms of its index. And then we do the same thing, but we reduce by 1 the index. Now, order of operations will ensure that this isn't done first, that division is done first. If you'd like, you can put parentheses around that to ensure, well, to make you feel comfortable, but the order of operations, remember, division is going to be first, so this will happen first, and then this will happen. But if you feel comfortable putting parentheses around it like this, that will do no harm. But just to prove it, I'll go ahead and execute this. We'll go ahead and send in even number of elements right here, because we're going to call the function by sending an even number of elements right here. And remember, 3 and 4, so it should return a value of 3.5 if we get the middle if it works. So let's see what happens. get the middle 3.5 so it works. Take a look at that and see if you understand how we first check to see if it's an odd or an even number of elements in the array, and if it's odd, we use the floor function to help us out, and if it's even, we simply have to divide by 2 and then find the previous one by subtracting 1 from it. Take a look at that and see if that